All right, so today we are going to get into a lot heavier trig than what we've been doing. So a lot of review in terms of special right triangles, sine, cosine, tangent, all of our trig ratios, that kind of thing. And now we're going to extend that into placing some angles, not just in the right triangle, but how we're going to create a circle with it, okay? So, mention circle. Tell me everything you know about a circle is how I started class. And so some things that were thrown out, right? It's round. It's always the first thing I hear. It's round. Well, yeah, sure it is. It's got a radius, right? It's got actually lots of radii. You can draw an infinite number of radii, an infinite number of diameters, and they're all going to be the same length. The radii are all going to be the same length. Diameters are all going to be the same length. Inevitably, I hear 360 degrees, right? That is the degree measure of a circle. If you go all the way around a circle, then you've gone 360 degrees. That is true. Okay. Also, usually hear circumference. It's got a circumference. That's true. The circumference of a circle is 2 pi r. So if you were to walk on a circle all the way around, then you would have gone 2 pi r distance. And that's usually where I get into reminding everyone that from geometry, that with a circle, right, in geometry, we took that circle and we created what's called a central angle, right? Vertex at the center. And we talked about whatever angle this central angle measure has, that's what this arc, that's an arc, right? The arc measure is the same. So the arc measure was always a degree measure. But then I remind them that we also talked about the length of the arc. So arcs have a measure and a length, and they're different. The length of the arc is how far you have to walk on the circle to get from one side of the angle to the other. That's not a degree measure. It's an actual length, right? And so we went through this reminder of how do we get that? Well, we would take the measure of the arc, compare it to 360, and that would be equal to taking the length of the arc and comparing it to the circumference, 2 pi r. Okay, this is what we did in geometry, right? We plugged in the measure, or we may have simplified, and we cross-multiplied, right? And what we should have done is we should have left our answers in terms of pi. But I'm showing you this because it gets us into a place where we start thinking about, yes, all the way around the circle is 360 degrees, but if you were to walk all the way around the circle, depending on what r is, you're going to walk 2 pi distance. And that kind of gets us thinking about radians a little bit. That's basically what a radians is. A radian is another way of expressing an angle measure, but it's going to be in terms of the length of an arc instead of the measure of the arc. Okay? Then we follow that up with tell me everything that you remember about a special right triangle, since we just took a test over it, right? And try to get you guys to understand 45, 45, 90 is one of them. 36, 90 is another. And in terms of their side lengths, 1 radical 2, 1 radical 3, and 2 for the 30, 60, 90, because that's going to come into play a lot for what we're talking about here too. Okay? All right, so a little bit of an intro of where we're going with this. Okay? So with this video, by the time we're done, you should be able to use a degree and a radian measure. You should be able to convert between degrees and radians, and then know what a coterminal angle is. And so we start. And we start by taking a step back. So we're going to step out of a right triangle and just talk about angles in general, right? We know that angles have a vertex. They also have 2 sides. But what we didn't talk about in geometry is that one of the sides here we're going to call an initial side. So it's this side. We're going to start drawing with this side. And then the other side is called a terminal side. It's just where the angle ends. It's just the other side of the angle. Okay? So initial and terminal side, and of course remember vertex. More definition work. If an angle, so if I were to draw an initial side like this, then I could create an angle one of 2 ways. I can either go up this way and draw an angle, or I can go down this way and draw an angle. If we go up, then we're moving counterclockwise, right? A reverse, opposite direction of a clock. If we go counterclockwise, then that angle is going to be said to be positive. That's your positive angle measure. And as we saw from last unit, we've got some negative angle measures. A negative angle measure happens when you drop down here and go clockwise. Start opening up an angle clockwise. This is going to be a negative angle measure. Okay? And of course, we know that angles can be acute, they can be obtuse. So this is still going to be a positive angle measure, just an obtuse one. If we consider the fact that I could draw an angle anywhere, even out here, right? If I go this way, if I go clockwise, then I can create an angle this way. I can create an angle that way, that way, that way. So really we can go all the way around a circle. Okay? If we go all the way around in a circle, then we're talking about going around one rotation or one revolution, right? So one revolution would be theta here, right? And just a reminder, if we go around a circle, how far have we gone? Yes, 360 degrees. But in terms of distance and length, we've gone 2 pi r. I want to keep linking those two ideas. Okay? All right. Next, all right, what we're going to let represent these angles. And we've seen 2 of these already, beta and theta. We'll also use alpha, which is kind of a script-looking A there, and then gamma, which is kind of like a script-looking Y. But those are the 4 primary Greek letters that we use to represent angles. Okay? All right. Now, next definition. An angle is said to be in standard position if its vertex is at the origin, okay, and if the initial side sits on the positive x-axis. Okay? So, I'm going to use one of these coordinate plane, one of these set of axes down here to show what we're talking about, right? So, in standard position would be an initial side that sits here on the positive x-axis, and then can open up in any direction. Now, if we keep the terminal side the same length, right? Say here, we can, I mean, it's almost like it's on a hinge, right? I can open up the angle there, all the way around, right? If I fill in all of these angles, eventually I'm going to get to a point where all of them have the same terminal side length. I'm going to make a circle, right? That's how we end up putting an angle in a circle. Because I know that if I'm in standard position in a coordinate plane and that terminal side has a fixed length, I can open up that angle anywhere I want and eventually make a big O circle. Okay? So I want to make sure that we understand why we're going to eventually talk about circles. Now, going back to the standard position, we're in a coordinate plane. Some things that you need to remember about a coordinate plane. Coordinate plane has quadrants, right? So remember where the quadrants are. Quadrant 1 is this top right-hand side. Quadrant 2 is top left. Quadrant 3 is bottom left, and quadrant 4 is bottom right. Okay, we need to understand and remember those quadrants, and then we're going to want to make sure that we keep in mind what quadrant we're supposed to be in and when. Okay? All right, so to use that. First example here, we want to draw an angle that's in standard position, is positive, and lies in quadrant 3. Right? So standard position means the initial side's on the x-axis. Positive means we're going to rotate around, and then we're going to end up in quadrant 3. That means that we're going to end up out here. And so that's going to be your angle. And usually we show an arrow to let us know which way the angle opens up. You'll know which way the angle goes, either it's clockwise or counterclockwise, depending on the measure, if it's positive or negative. But if you don't have the measure, then you're going to know by these arrows as well. Okay? Next one wants us to put an angle in standard position that's negative and ends up in quadrant 4. Well, negative means I'm going this way, and to end up in quadrant 4 means I'm going to stop right here. So that's going to be a negative angle, negative theta. Next question is, put an angle in standard position that's positive and is a quadrantal. A quadrantal angle is an angle whose terminal side coincides with an axis, right? The terminal side is going to be sitting on an axis. So our initial side is here. Our terminal side could also be right here, or it could be right here, or it could be right here, or it could be right here. Those are all the axes, right? All right, let's take that a step further. So in standard position, positive is a quadrantal. Those are all quadrantals, right? In terms of their measures, right? First off, the purple quadrantal. This is going to be 0 degrees because it hasn't opened up at all yet. The green is going to be 90 degrees, right? That's a 90-degree angle. The blue, if we go all the way to where we're pointing back, that's 180 degrees. We know all that from geometry. The orange, though, keep following the pattern, right? 90, 180. Maybe I need to add 90 again. This is going to be 270 degrees. That's how we get to an angle bigger than 180. Because we're in this idea of creating a circle. Now, if we go all the way back around, we can go all the way back around, and then we get a quadrantal that lands on the positive x-axis again, and we call that 360 degrees. Okay? Now, this is where you want to pull out that blank unit circle, that single sheet, and you start filling in angle measures, because all of the quadrantals are going to have those angle measures, right? So you want to stop the video for a second, fill those in. You're going to have to memorize those. Okay? All right. To move on, the idea of coterminal angles. Coterminal angles are two or more different angles whose initial and terminal sides coincide, right? So in other words, I've got an angle that has an initial side here and maybe a terminal side here. And a coterminal angle, and maybe this is, I'll draw it this way. So maybe this is 30 degrees. A coterminal angle would be as if I went around the circle again and ended up here, where the terminal side is the same, right? But if I go around the circle, then I've gone 360, right? So if I start at 30 degrees and I go around 360, I'm going to add them. This ends up being 390 degrees. That's a coterminal angle to 30 degrees, and I've already done the first example, right? But that's a coterminal angle. They're two different angle measures, but their terminal sides are in the same spot. So whatever is true for a 30-degree angle, that's also going to be true for a 390-degree angle. Okay? That's what I mean by coterminal. Now, we can keep going around and around and around and around and around an infinite number of times. So an angle has an infinite number of coterminal angles. To find an angle that's coterminal to a given angle, I've already alluded to it. We're going to either add 360 or subtract 360. If we want to go clockwise and go towards the negative, then we can just subtract 360. Okay? Now, I'm going to add in here, or we can add or subtract 2 pi radians. Again, we'll talk about radians more in a second, but why 2 pi? Because again, if we go around the circle, we are traveling 360 degrees in terms of a degree measure, but we're also traveling 2 pi, depending on the radius, 2 pi in terms of a distance. So 2 pi radians, okay? All right. Go back. We've got some examples here. Now, assume that all these angles are in standard position. Find a positive angle that's less than 360. So there's some conditions that we have to follow. That is coterminal. So we want to find a coterminal angle. But unless we are given some conditions, then we have an infinite number of possible answers to come up with. So this sort of narrows our focus down to just a positive angle that's less than 360. Well, to get there, if I'm at 390 and I want a coterminal angle that's less than 360, then I got to back off. I've got to subtract 360 from 390. When I do, I get 30, and so like I said before, I did the first example already. So a 30-degree angle is a coterminal angle that's less than 360 and positive. 405 degrees. Again, I can subtract 360 because I want to get lower and end up with 45 degrees. So whatever's true about a 45 degree angle, that's also going to be true about a 405 degree angle because they're the same in terms of their positioning. And then negative 135. Well, I don't want to subtract 360 again because I'll just get more negative, and I want to be positive. So I got to add 360. And that gets me 225 degrees. Now the last one, 13/4 pi. Now that's not in the degrees. That's in what's called radians. So I want to be less than 360. That's true, because 360 is all the way around a circle one time. But in terms of a distance, so is 2 pi. So I want my angle to be less than 2 pi. This last one, that is. So the question is it less than 2 pi already? And just a heads up, you are going to have to get good with fractions. You got to make your peace with fractions because everything that we do in radians will be in terms of fractions. Adding and subtracting fractions, dividing fractions, all of that stuff, you have to remember fractions. So when I see 13/4, you're going to have to either right now or very, very soon be able to tell me that that is actually 3 1/4 in terms of a mixed number. 3 1/4 pi, which means that it's 3 pi's and then 1/4 of a pi, which is definitely more than 2 pi. So that means I have to subtract 2 pi from it to get a coterminal angle that's less than 2 pi. Now remember, if you're going to subtract fractions, you've got to have common denominators. So that 2 pi has turned into 8 pi over 4. Then you subtract the numerators and you get 5/4 pi. That is less than 2. It's 1 1/4 pi, so it's less than 2. So that's our coterminal angle. Okay? But you got to get good with fractions. All right, that's how we find coterminal angles. Now we can subtract or we can add either way. All right, a radian. By definition, a radian is the measure of the central angle, so it's still an angle measure, but it comes from where the angle measure is, how big this angle measure is, how big this guy is right here, comes from, we're going to open up that angle to where the arc length, so this length right here, is the same as 1 radius. That's the definition. Now, if you can't remember that definition, 2 weeks from now, it's not going to be the end of the world. But that's what a radian is. And I wanted to tell you so that you knew when we talk about radians what we're talking about. We're trying to open up an angle to where the arc length is the same as the radius of a circle. So 1 radian would be if we opened up one arc length that's equal to 1 radius. 2 radians would be if we open up an angle to where the arc length is 2 radii. And then 3 radians, 3 radii, so on and so forth. Okay? Where the radians measure comes from is we take the arc length and we divide it by the radius, right? So when we say that there's a radian of 5/4 pi, that means that the arc length that we opened up to is actually a fourth times longer than the radius. So it's 1 radius plus an additional 1/4 of the radius, right? It's kind of what we're talking about. So we're taking the arc length and dividing it by the radius. So it's a piece of the circumference. Again, circumference is 2 pi r. And the reason why we express all of our radians in terms of pi, and we will, is because you can see there that the radius kind of gets divided out into the arc length. And so instead of thinking about going around the circle in terms of 2 pi r, we go around the circle in terms of 2 pi. Okay? But it's still an angle measure. So you'll still have sine, cosine, tangent for it. And we'll talk about that more later. Right? So an angle is going to be measured in degrees, and you'll know that because of the degree symbol, little circle. An angle measured in radians, we won't write the word radians out, like right here. You won't see radians. You'll just see the measure. Now, most of the time, if not all the time, a radians measure will be in terms of pi. So, for example, pi over 2 is a radians measure. Pi over 2 is meant to mean pi over 2 radians. We just don't say the radians or write it down. Okay? So that's where it comes from. Now, this is the unit circle that I handed to you, and right now we should be able to fill in all of these angle measures, the quadrantals. We talked about that already. Okay? What we haven't talked about is that the spokes on the unit circle all correspond to your special angles. That's why we talked about them at the beginning of the video, right? 30, 60, and 45. Each spoke corresponds to either a 30, a 45, or a 60-degree angle of some sort, right? So this first spoke is as if we've got a 30-degree angle. The second spoke is as if we've got a 45-degree angle. And the third spoke is as if we've got a 60-degree angle. Okay? So those are your angle measures in that first quadrant. Your first quiz is only over that first quadrant. And it's the quadrantals as well. So angle measures, and in a minute we'll talk about how to get the radians. But we'll come back to this in a second. All right. Well, what we do have to understand is, especially the quadrantals. If we go back to the unit circle, the quadrantals, the parts on this unit circle where the terminal side is on an axis. We've done the angle measures for those already. If we're going to start drawing angles with radians measures, it would be helpful if we did the same thing in radians mode, right? So, again, if your one of your quadrantals is without opening up a circle at all, so 0-degree angle is going to have a 0 radian measure. Okay? The next one is if we went to the positive y-axis. That had a 90-degree measure, right? Next one was 180. The next one was 270. And then if we come all the way back around, we're at 360. Now, to fill in the radians measure, I'm going to work backwards. I'm going to ask you again, in terms of length, how far do you go if you go all the way around a circle? And hopefully you're thinking 2 pi. So that radians measure is going to correspond to 360 degrees, 2 pi. Okay? Well, take half of 2 pi and you're going to go half a circle. Half of 2 pi is pi, half a circle is sitting right here at 180 degrees. If you take half of 180, you end up at 90 degrees, which means that positive y-axis. Well, that means in order for you to get its radians measure, you have to go take half of pi, which is going to be pi over 2. That's another half pi. Now, go back down. Halfway between 180 and 360 is 270. To get its radians measured, halfway between pi and 2 pi is 1.5 pi, or as a mixed number, 3/2 pi. So that's the radians for your quadrantals. You need to write that down in your unit circle and remember that for the next quiz. Okay? This will also help us in trying to figure out how to draw an angle whose radians measures are given here. Right? 4 pi over 3. I think it's helpful to think in terms of pies, whole pies, right? In other words, convert this to a mixed number. 3 goes into 4 one time with 1 left over, so 1 in the third. That means that 4 pi over 3 radians that's going 1 pi and then a third more pi, right? So that means that we're going to go 1 pi here and then a third more pi. So a third is less than a half. So it'll be somewhere right in here. I don't want to go another half pi. So I don't want to go all the way over to 270 or the 3 pi over 2. I'm going to go 1 full pi and then a third, which is less than a half. So I'm not going to go down to the half. I'm just going to stop there. So that means that I'm going to draw, well, first I should draw a coordinate plane. And then put this in standard position. And then that means I'm going to go 1 pi, but then another third puts me here. So another third puts me here, and this is 4/3 pi. So we end up in quadrant 3. 21 pi over 4 is going to be the same deal. You draw an xy axis. Okay, 21 over 4 is 5 1/4. That means I want to go around once to get to 2 pi, but I need to go 5 pi's. That's just 2 pi's. Go around again, that's 4 pi's. So then I want to go one more pi, which puts me there. That's 5 pi's. Okay? From there, I need to go a fourth of a pi more. Since a fourth of a pi is less than a half, I'm going to end up down here in quadrant 3. So my angle would look like this. Okay? Negative pi over 6. Draw your coordinate axis. Okay? Negative now, careful. Negative means we're going to go clockwise. Now we're going to go down. But how far? Do we want to go 1 full pi? No. We don't want to go all the way over here because that would be 1 full pi, and that's too much. How about half? Do I want to go to the next quadrantal? Do I want to go half a pi? Well, 1/6, which is what that is less than a half. So I don't even want to go another half. So negative pi over 6 is somewhere in this 4th quadrant, like this. Okay? And then the last one, we've got xy axis. Start here. Negative 16 over 3 pi. Again, I want to go clockwise, but this is going to be negative 5 1/3. Right? So that means I'm going to go clockwise, 1 full, which is 2 pi. Another full, which is 4 pi. Then I want to go another 1 pi, which puts me there. That's 5 pi's. And now I need to go a third more. A third is less than a half, so I don't want to go up to the positive y-axis. It's going to put me somewhere in here, in quadrant 2. So I draw my angle here in quadrant 2. Okay? Hopefully that makes sense. If not, come see me and we'll figure it out. Now, converting the measure to radians. So if I'm going to go 9/10 of a revolution counterclockwise from the x-axis, that means that counterclockwise is positive. From the x-axis, that means I'm going 9/10 of 1 revolution. Remember, 1 revolution is 2 pi. So to find 9/10 of 2 pi just means I'm going to multiply 9/10 times 2 pi. I'm going to divide these out before I multiply straight across. Remember, make these fractions, you multiply straight across. 9 times pi is 9 pi. 5 times 1 is 5, so we get 9 pi over 5. Okay? Next, 1 1/3 revolutions, right? I want to go 1 full revolution, which is going to be 2 pi, but it's going to be more than 2 pi because I want to go a third again. So the easiest way to figure this out is to turn this back into an improper fraction. Make this 4/3. But 4/3 of a revolution would be 4/3 times 2 pi. You make this a fraction by putting it over 1. And then you can multiply straight across and make this 8 pi over 3. All right? All right. Next, converting between degrees and radians. Now this box suggests a very visual way for converting between degrees and radians. Okay? If you're going to convert from degrees to radians, take your degrees and multiply by pi over 180. And like I said, if you're very visual, you're going to want to see that. If you convert from radians to degrees, multiply radians by 180 over pi. You can set that up, do some simplifying, and that becomes very easy. I tend to think of it in a little bit different way, and I'm going to talk to you about both. Okay? Here's how I like to do it. I'm going to go on to the next slide and just get into converting these. 135 degrees, if I want to make that into radians, okay, I need to divide the degrees out. The degrees needs to go away somehow. And since I know that pi and 180 are the same, right? 180 is the degree measure, pi is the radian measure for the same angle. That means that I'm going to take the degrees out of 135 by dividing it by 180. And then when I'm done simplifying, and I just want to simplify this fraction, I don't want to get a decimal. When I'm done simplifying, I've got to put the pi in. So I'm going to slap a pi on it. So 135 over 180 reduces down to I know that 5 will go into both of these, so 27 over 36. 3 will go into both of these now, so 9 over 12, and 3 will go again, so we go 3/4, and then slap a pi on it, so 3 pi over 4. That's 135 degrees. Okay? That's how I do it. I just divide all of my degrees by 180, simplify it, and put a pi on it. If you want to see it visually, what the box on the last slide said to do was take negative 120 and multiply it by pi over 180. Which, if you pay attention to what I did in the first one, it's basically what I've done. But make this a fraction, multiply straight across, and then simplify your negative 120 over 180. So it becomes negative, 10 will go into both of those, so you get 12 over 18. And then 6 will go into both of those, you get negative 2/3 pi. That's another way to do it. Personally, again, if I'm going from degrees to radians, I want to take degrees out, put radians in, so I'm going to divide by 180. And so when you do that, you want to simplify here. You get negative 15 over 18, and if it takes you 2 or 3 steps to simplify, it's fine. Negative 5 over 6 pi. Okay? And then 90 degrees, right? Divide by 180. That's actually just a half. So we get 1 over 2. Pi is in the numerator, so just get pi over 2. And we've seen that already on our quadrantals of our unit circle. 180, just divide by 180, and you get just pi. Okay? All right. To convert radians over to degrees, like I said before, pi and 180 are the same. So we can just substitute 180 in for pi. That's what I do. Right? So just make this 180 over 2, divide it out, and you get 90 degrees. Okay? Now the box in the previous slide suggests that you should multiply by 180 over pi. And that'll work too. The pi's divide out here, you get 180 over 1, or just 180. Whatever way you want to do it. I like plugging 180 in for pi. So I'm going to make this 180 over 3. So you get negative 60. So you're either dividing by 180 to divide the degrees out, or you're plugging 180 in for pi, since those are the same. Same thing here. 5 times 180 over 6. Now I'm going to be smart, and I'm going to simplify the 180 over 6 first. To give me 5 times 30, and then multiply that out and get 150. 2 pi over 3 means I'm going to take 2 times 180 over 3. I'm going to divide that out and get 2 times 60, which gives me 120 degrees. Okay? And now we can convert from degrees to radians, radians to degrees. All right? And that's it. Now, we could come back to these examples down here to sketch these angles, right? A couple more examples here to sketch angles. If you wanted to sketch 7 pi, right? Take a second. Start here. Go around 2 pi. Go around 4 pi. Go around 6 pi. And then go around one more to get to 7 pi. That's where you're going to end up. So 7 pi is that angle right there. 4, look at 4. B. 4 is not a radian. Radian has pi in there, right? That's just 4. Well, think about this again in terms of the unit circle, right, in your quadrantals. Again, this was 0 or 2 pi, right? This was pi. This was pi over 2 because it's half. This is 3 pi over 2. But remember what pi is. Pi is 3.14, right? Well, it's more than that. But we can start with 3.14159, whatever, right? Half of pi, if you were to divide that out, will give you 1.57 roughly. 3 times pi divided by 2 would give you about 4.71. And then 2 pi would basically give you 6.28. So if your measure is just 4, then it's apparently we've multiplied the pi out. And so we would end up somewhere in quadrant 3, because that gets you between 3.14 and 4.71. Okay? And the last example down here, if we need 2 coterminal angles, one positive and one negative to the one that's given, well, remember that we want to add 2 pi, because we're going to go around in a circle in 2 pi. Okay? Now, to add that, I've got to make common denominators. Then I can add those, and I get 28. Oh, sorry. That's supposed to be a 15. So we get 28 pi over 15. Now, to make a negative one, I'm going to take this and subtract it. So I'm going to get negative 32 pi over 15. Okay? All right. So there you go. There's your introduction to radians. Hopefully that makes enough sense. Try the homework. If it doesn't make any sense, make sure you come in to see me. All right?